I know the last few weeks have been a little bit crazy, a little bit all over the place, but we're going to be starting going over the review sheet today. Now, we only have 25 minutes, so we won't get everything done today, but we're going to go over as much of it as we possibly can. So we're going to go on and start off with this here. So when we look at this here, the first thing we're looking at is these triangles here. Find the value of x and state if it's a Pythagorean triple. So for these first so many problems, we're going to be using the Pythagorean theorem to solve for the missing side lengths. And our Pythagorean theorem is a squared plus b squared equals c squared, where a and b are our legs, and c is always going to be the hypotenuse. C is always going to be the hypotenuse. So if I look at number 1, we're given 3, 4, and x. So the missing side length is the hypotenuse. It would be the value of c. So when we look at this here, we can plug 3 and 4 in for a and b. So we have 3 squared plus 4 squared equals x squared, because again, we're trying to find the hypotenuse. And 3 and 4 would be our legs, a and b. Now at this point here, we can solve. So we can do 3 squared plus 4 squared. We could plug all that into the calculator, or we can do 3 squared and 4 squared and add those together. Now 3 squared plus 4 squared would give us 25. So 3 squared plus 4 squared would give us 25. So we simplify that down. Now we have 25 is equal to x squared. So to get the value of x by itself, we would square root both sides, because the square root of x squared would be x. Now the square root of 25, we can plug this into a calculator, and it would tell us that it is 5. So the missing side length for this triangle here is 5. And because 3, 4, and 5 are all side lengths are whole numbers, it would be yes, this is a Pythagorean triple. Because Pythagorean triples work out only if all 3 side lengths are whole numbers. And here, all 3 side lengths are whole numbers. So we've done everything we need to do here. All right. If there are no questions on number 1, we can go on and look at number 2. Now, if we look at problem number 2, it's a very similar setup, because we're given 2 side lengths, 10 and 13. And, well, again, we're solving for the hypotenuse. Now, I know I'm solving for the hypotenuse because it's the side opposite the 90 degrees. Because whenever I'm solving for the side opposite the 90 degrees, we're solving for the hypotenuse, which means I'm going to plug 10 and 13 in for a and b, and we'll plug x in for the value of c. So we're just using the Pythagorean theorem and plugging in our numbers accordingly. Now at this point here, just like we did on the last one, what we could do is, because, well, since 10 and 13 are both on the same side, I have 10 squared plus 13 squared. Well, we can add this straight into the calculator. So we do 10 squared plus 13 squared. We can type this into the calculator. And if we type this into the calculator, we'll get 269 is equal to x squared. So we just typed that in. We didn't have to do anything with that. Now again, just like the one before, to get x by itself, we do have to take the square root of both sides. And when I take the square root of both sides, well, the square root of x squared gives me x. Now again, we can type the square root of 269 into the calculator. And if we type that into the calculator, the TI-30XS will give us the square root of 269. And we can leave it as that there. We don't have to turn it into its decimal approximation, which would be 16.40121947. and it's a non-repeating, non-terminating decimal. And that's all we have to do to solve for the missing side. Now, no, this would not be a Pythagorean triple because one of the side lengths, the hypotenuse more specifically, is not a whole number. Because it's not a whole number, this would not be a Pythagorean triple. And that's all we have to do for this here. That's all we have to do for this problem here. So before we move on to the next one, is there any questions on any of this here? Are we good with all of this here so far? Okay. I'm assuming from everyone's silence we're good with this here. If you do have questions, please ask. Okay. So let's look at the next two here, 3 and 4. Now these here are a little different. They're not completely different, but they're just a little bit different. Because we're still going to be using the Pythagorean theorem. A squared plus b squared is equal to c squared. So we will be using this here. And when we look at both of these triangles, we'll look at number 3 first. Well, this time they gave us the hypotenuse. They gave us the hypotenuse value of 25. So we're not solving for the hypotenuse. We're solving for A or B. We're solving for one of those two values. So that means x and 24 are the values of A and B. So we'll have x squared plus 24 squared is equal to 25 squared. We'll have it set up in this way here because 25 is the hypotenuse. Now for this one here, we can't just plug everything into the calculator because not all the numbers are on the same side. 24 is on one side of the equal sign and 25 is on the other. So what we can do is we can plug 24 squared into the calculator and it'll tell us that it's 576. And we can plug 25 squared into the calculator and it'll tell us that it is 625. So we can type those into the calculator to simplify it a little bit. Because again, our whole point in doing this is to get the value of x by itself, or get x by itself. So the first thing we can do is square 24 and 25 and get 576 and 625 respectively. Now the next step in getting x and solving for the value of x is to get x squared by itself. And to do that, we can subtract 576 from both sides. Because 576 minus 576 would cancel, giving us x squared is equal to 25 minus 576 would be 49. So we subtracted it from both sides, which gave us x squared by itself. And last but not least, we'll need to take the square root of both sides. And when we take the square root of both sides, we get x is equal to 7. Because the square root of 49 is 7. Which tells us one of the side lengths, the missing side length, the one that we were solving for, is going to be 7. And that's it. That's all we need to do for this problem here. Now, because all three side lengths are whole numbers, I'll scroll back up because this side length is 7. Since we have 7, 24, and 25, yes, this would be a Pythagorean triple because we have 3 whole numbers. The only way that we can have a Pythagorean triple is if we have 3 whole number solutions. Any questions on any of this here? Any questions on anything we've gone over so far? All right, we'll look at one more of these here before we move on to the next type. Let's look at number 4. Now, number 4, again, when we look at this here, is 17. The hypotenuse for this is 17. So they gave us the hypotenuse, which means we're solving for the values of A or B. We have to solve for one of the two side lengths. So A and B is going to be our 8 and X, and we can plug them in. So we're going to have X squared plus 8 squared equals 17 squared. We plugged in for the values of A and B and C. So this is very similar to the one we just did. So once we have this set up, we're just solving for the value of X. So when I look at this here, well, the first thing we can do is simplify 8 squared and 17 squared. We could plug those into the calculator. So we could type 8 squared into the calculator, and 8 squared is 64. And we can type 17 squared into the calculator, and we would get 289. So the first real thing we did is we typed 8 squared and 17 squared into the calculator and got 64 and 289 respectively. Now again, we're trying to solve for the value of X. So the first thing that we need to do, or not the first thing, but the next thing we need to do is to get X by itself. And we can do that by subtracting 64 from both sides. And when we subtract 64 from both sides, we get that X squared is equal to 225. So we're almost done. We got X by itself. There's nothing out here subtracted, but it is squared. So to undo a square, we have to take a square root. So the radical and square root would cancel. And we could plug the square root of 225 into the calculator, and it will give us 15. So this here would be, yes, it is a Pythagorean triple because all three side lengths are whole numbers. And our missing side length is 15. Now, will it always work that we have 3 whole number side lengths? Well, no. It doesn't just work with hypotenuse. The hypotenuse being a decimal number, the side lengths can be decimal numbers too. It just worked out that these two problems here gave us 3 whole number side lengths. It worked out that this is 15, so this is yes. So both of these worked out to be Pythagorean triples. They won't always work out to be Pythagorean triples, but these two here did. And that's here is what you're using the Pythagorean theorem, our a squared plus b squared equals c squared. And there's more examples of these here. Do you all need to see another example of one of these here using the Pythagorean theorem? All right, if we are good with this here, let's move on to 7 through 11. Determine if the following triangles are right triangles. Well, this is going back to the Pythagorean theorem because a squared plus b squared equals c squared works if and only if, this is true if and only if it is a right triangle. So a squared plus b squared equals c squared is true if and only if it is a right triangle. So we look at number 7. C is always the hypotenuse. It is always the biggest side length. So for us here, 29 would be the hypotenuse because 29 is the longest side length. So 29 squared is going to equal, or should equal, 20 squared plus 21 squared. And if this is a true statement, if 29 squared is equal to 20 squared plus 21 squared, then it is a right triangle. And now at this point here, all we need to do is plug this into the calculator to see if this works. So the first thing we can plug in is 29 squared. And 29 squared is going to be 841. Now we can plug both of these in. And we can do 20 squared plus 21 squared. which also gives us 841. So these are equal. So this means that this is a right triangle. This would be a right triangle because a squared plus b squared equals c squared. It does work out. And that's all we have to do for this here. Okay, let's check another one. Let's check this one here, number 8. So again, if this is a right triangle, so the hypotenuse would be 62 because 62 is the longest side length. The hypotenuse is always the longest side length. So 62 squared should equal 11 squared plus 60 squared. Because if it is a right triangle, a squared plus b squared equals c squared. So when we look at this here, we can plug these into the calculator. We can do 62 squared, and 62 squared is 3,844. And we want to see, does this equal 11 squared plus 60 squared? Well, 11 squared plus 60 squared is 3,721. Okay, those two are not equal, so that means this is not a right triangle. Because the only way that this can be a right triangle is if a squared plus b squared equals c squared. And for this problem here, a squared plus b squared did not equal c squared. So it didn't work. So it would not be a right triangle. So if we're wanting to determine if the three side lengths form a right triangle, well, all we need to use is the Pythagorean theorem, a squared plus b squared equals c squared. And we use this here, we could plug them in to see if it works. And that's it. That's what we would do with these here also, is we would plug them in for a, b, and see, does it give us a true statement? Does a squared plus b squared equal c squared? Does anybody need to see another problem of one of these here? All right. Let's look at these next set, 12 through 17. Determine if the following triangles are acute, right, or obtuse. Now again, with these here, we're going back to the Pythagorean theorem. A squared plus b squared is greater than c squared if it is acute. A squared plus b squared equals c squared if it is right. And a squared plus b squared is less than c squared if it is obtuse. If it's an obtuse triangle, a squared plus b squared is going to be less than c squared. And we'll use these here to determine if it is right, acute, or obtuse. Now all we have to do at this point here is to plug the numbers in. Now again, c is always going to be the hypotenuse. So our hypotenuse for this here is 109. Now this one here, I'm not going to set them equal because we don't know for sure if they are going to be equal. They might be equal, but they might not. So we'll leave the hypotenuse by itself for now. We'll see what it equals. Now a and b would be 60 and 91. So we'll do 60 squared plus 91 squared. And again, at this point here, we can type all this into the calculator. So the first thing I can type in is 109. So we can do 109 squared. And if we do 109 squared, we get 11,881 is our number. Now 60 squared plus 91 squared will give us 11,881. Well, those two are equal. And since they're equal, that means that this here is a right triangle. Because if a squared plus b squared equals c squared, because they gave us the same value, 109 squared and 60 squared plus 91 squared gave us the same value. This would be a right triangle because a squared plus b squared equals c squared. And that's all we'd have to do for number 12. Okay. I'm going to erase this here so that I can move these over here. Now the next one we'll look at is 13, 7, 8, 9. Now 9 would be the hypotenuse because again it is the biggest side. The biggest side is always going to be the hypotenuse. So we want to see what the value of c is, c squared, or 9 squared is. Now a and b are going to be 7 and 8, so we'd have 7 squared plus 8 squared. And again, we do this individually so that we can kind of compare how 9 squared and 7 squared plus 8 squared, how do they relate? Now 9 squared, we can plug it into the calculator and we would get 81. Then we can also plug 7 squared plus 8 squared in the calculator and we get 113. Well, 113 is going to be greater than 81. A squared plus b squared is greater than c squared. So for this here, our triangle would be acute because a squared plus b squared was greater than c squared. So we get this here. And that's all we have to do for this problem here. Now that brings us to the last one. This one here, 15, 112, and 140. And we'll need to solve this one here. And we can do the same thing. We can take 140 because that would be the value of c and see what it equals. And now a and b are going to be 15 and 112. So we do 15 squared plus 112 squared. And at this point here, I would just type it into the calculator. 140 squared is going to be 19,600. Now we can do 15 squared plus 112 squared. And if we type this in, we'll get 12,769. Well, 12,769 is less than 19,600. So the value of c is bigger than a squared plus b squared. So this triangle here would be obtuse. This would be an obtuse triangle because a squared plus b squared is less than c squared. And really, when we do any of these here, we're going back to the Pythagorean theorem. This a squared plus b squared equals c squared for right triangles. A squared plus b squared is less than c squared, is acute, and a squared plus b squared, a squared plus b squared is greater than c squared for acute, and a squared plus b squared is less than c squared if it is obtuse. So I would make sure to have those written down because those will be helpful in solving and determining whether the triangle is right, obtuse, or acute. So that'd be helpful for us to be able to find it. Now, will it tell us exactly if the triangles, what the angles of the triangles are? Well, no. We wouldn't be able to determine what the actual angles of them are, but we would know if a squared plus b squared is greater than c squared, all the angles would be less than 90. If a squared plus b squared is less than c squared, one of those angles is going to be greater than 90. We can't really tell which one it is or what the exact value of that angle is with normal trig functions, but we know that it would be obtuse. Now we could get in the law of sines and law of cosines to actually find out what those values are, but at this point here we don't have a way to solve it. We haven't covered a method for solving these here. Now at this point here we're going to call this good. We will continue with the review tomorrow. So again, all of you that have tuned in for the Google Classroom have gotten your attendance for today. And we will be done with that there. So y'all can go on and sign out.